Okay, good day, Professor. On this day, I talk about the workshop 8, and it's about multi-body dynamics full evaluation for open and closed systems. And the main objective from this workshop is to evaluate and simulation of forces on tires. Okay, I'm Ramos Tomarullo, and go to the steps. And the first step is explore some menu options. Okay, this is very important, was very important for all the workshops. With this option, you can see open and you can open and unsafe works. And the next step is activate manager plugin system. And this is very important before starting the workshop, because you work with an card track. Okay, the third step is to create a full vehicle assembly. For this part, you select file option and assembly from open option. And after that disappear this box, and you right click and select this option from search, and after that you select MC tractor semi trailer, and you press OK, and it's appear the full vehicle assembly. Who is that? The next is verify system units. This is very important because you must to work with MMKS units. And okay, after the full vehicle assembly, you simulate this. And for this part, you go to simulate option and select single line change from these options. Okay, it's appear this box, and you can see all the behaviors with this, and you must to change. For example, the output prefix for this simulate is the test1, and the end time is 10, the number of steps is 100, the initial velocity, which is very important, is 60 kilometers per hour. Okay, the animation results. For the animation results, you go to the review option and select animating control. You select the test one and you go to the simulation. Okay, on this part you can see the simulation of the test one. Okay, you can see the maneuver who do the trailer, and this is very important for after with the plotting results. Okay, that is two simulation is on this part you only change the initial velocity, who is 50 kilometers per hour, and you can see the simulation. On this part, the only difference is the initial velocity, and you can see the maneuver who does the trailer. Okay, and all the behaviors is the same. And the plotting analysis result, you press F8 and disappear these windows, the Adams card post processor. Okay, the video from the test one. Okay, you can the maneuver who does the trailer. This maneuver change the plot results. You can see here the root behavior who does the trailer. And after I explain this. Okay, that is one is the rear. On this part, in the following plotting results, we can see how it affects the deflation of the tires of trailer. In this case, we have two axes together in the back. The rear two, who is color red, which is the last and rear. The penultimate in this case is the rear, only rear. In this case, we see the deformation that both suffer when they have an application of forces to the abrupt change of direction that the trailer has. And we see the rear axle 2 has a greater deformation due to the fact that that is in the last part, causing the forces applied to it to be greater than those of the rear. We also see that after the trailer ends its abrupt change of direction, both return their initial state. Okay, video this one is the trailer, from the trailer, deflection trailer. On this part, you can see on the maneuver who does the trailer. And this is similar to the rear simulation. Okay, the test one trailer. On this part, you see the same behavior. In the following plotting result is the same that the last plotting. We see how it affects the deflection of the tires of trailer. On this case, we have two lines, the trailer and the trailer 2, the trailer who is color red and the trailer 2 who is color blue. It's similar to the plotting results of the rear. In this case, we also see how the deflection affects on how it returns to its normal state once the road maneuver of change of direction finishes. And this is the plotting result from the test 2 with velocity 50. About the plotting result of test 2, in this case, we use a lower initial speed at 15 kilometers per hour. And if we look at the axis and the deformation it had is less at less speed. Since in the plotting result of the test 1, it had a speed of 60 kilometers per hour, and the deformation came to have about 22.5 millimeters. In this case, it's smaller, only reaching 21.5 millimeters. Okay, workshop question. How forces on tires affect chassis system? Okay, the resistance to rolling is a force that affects the pneumatic. It's practically the force that impedes the movement, and also depends on the chassis, because if it has more weight, there will be more friction and the vehicle will move slower. Also depends of the coefficient of friction of the material that is made the tire and that of the surface. The centripetal force, this force that normally appears when there are a curve extremely necessary, since it helps to turn around quite well. Also that is transferred as force to the chassis and also affects the center of gravity of this. What tires speed rating? The speed rating of tire indicates the optimum speed that tire can maintain safely over time. In short, it's is the fastest speed a tire can handle before it stops working as designed. This speed rating system is designed to help control the safe performance of tires at standard these speeds. In this case, the letter V indicates the velocity who the tires can go. For example, on this part, the symbols of the velocity. The letter Q, for example, the standard speed is 110 kilometers per hour, for example. Does nitrogen make a difference in tires? Okay, as a general rule, the inflation with nitrogen is always a good option to preserve the life of the tires. Since, in addition to the advantage already mentioned, it has many more benefits. For example, it keeps tire pressure for longer and more stable. They are not affected by high temperatures or sudden change. It favors to save fuel. It emits less CO2 than the tire than oxygen, for example, care more about the environment. It's compatible with any tire, for example.